Alright, this part of the notes is actually the most important formula from these notes. So if you only get one part really down, this is the one. It's molarity, and that's the most commonly used unit for concentration in chemistry. So remember that 1 liter equals 1,000 milliliters. We're going to use that conversion quite a bit. And here's our formula for molarity. Molarity is the moles of solute divided by liters of solution. It's important to make sure that you always have liters of solution in the denominator, not just liters of the solvent. Also, the solute. Don't forget, you have to convert to moles, so we're going to be using molar mass. Let's go ahead and get started with our first example. I have 100.5 milliliter intravenous solution. Okay, there is our volume of solution. It contains 5.10 grams of glucose. You have the formula for glucose. What's the molarity of the solution? And it gives us the molar mass for glucose, so I don't have to add that together. So, our formula is molarity, which is what I'm looking for, equals moles of solute, which we could represent that by the letter N, moles of solute. I have 5.10 grams, and I've got my molar mass here, 180.16 grams are in 1 mole. I want to convert it to moles. Again, our grams cancel out and I'm left with moles, which is what I need in order to use this equation where I have moles of solute divided by liters of solution. So let's do that real quick. 5.10 times 1 over, I believe it's 180.16, 180.16. .0283 0.283 moles of solute. And then our liters of solution, that's the volume. The number of liters of solution, I have 100.5 milliliters. Remember, I need to convert to liters, so I'm going to have 1,000 milliliters, 1 liter. Or you might remember from when we did conversions with the metric system that you can just move the decimal 3 places. Either way, you're going to end up with liters. 0.1005 liters. Now we just divide. Molarity equals the moles over liters, so I have 0.0283 moles divided by liters of solution, 0.1005. .282. 282 molar solution. There's your molarity. Okay, let's look at number 4. This time I'm looking for the volume. I want the volume of a solution. I have the molarity here, and I have the number of moles of solute right there. So molarity is given 0.452 molar. In the number of moles is given 3.56. Volume is given, or it's not given. Volume is what I'm looking for. What's the volume? And I'll find that volume in liters. So I have 0.452 equals 3.56 moles over liters over V. So I can't find V if V is in the denominator. So the first thing I would do is multiply it across so that I can get V out of the denominator. So I end up with 0.452V equals 3.56, and then solve for it by dividing by 0.452 on both sides. Unless you're really, really solid in math, it's good to go ahead and take 2 steps to do this problem so that you make sure you don't make a mistake and leave V in the denominator. V equals 3.56 divided by 0.452. $7.88. $7.88 liter sample. All right, now let's look at the next one, number 5. What's the mass of KNO3 that's needed to make 9,924 milliliters of a 1.22 molar solution? Okay, so what I have is volume and molarity. So I've got my molarity. My volume is 9,924 milliliters. If I want to convert that to liters, that's going to be 1,000 milliliters on the bottom, 1 liter on the top, or you can just move the decimal 3 places. Just make sure you're moving it the right way. Canceling out units, ending up with liters. I'm going to get 9.924 liters. I don't know what N is. Now remember, N is the number of moles in the moles of solute. So if I solve for it, it's going to give me moles of KNO3. That's not what I'm looking for. I'm looking for mass of KNO3. So after that, I'm going to have to convert to grams of KNO3 using the molar mass. So that's kind of our schematic of the way we're going to solve the problem. I now have liters and molarity, so I can go ahead and start so that I could solve for how many moles I am going to need to make this solution. So I have 1.22 molar equals N over 9.924. So to solve for N, I just need to multiply those two numbers together. N equals 1.22 times 9.924. You get 12.1 moles. Remember that I'm actually not looking for moles. So this is our next part. 12.1 moles. I need to convert that to grams. Remember, our substance is KNO3, so 1 mole of KNO3. And often the molar mass will be given to you, but if it's not, you'll need a periodic table to figure out how many grams of KNO3 there are in 1 mole of KNO3. So I've got my periodic table here. K is 39.098. N is going to be 14.007. And the mass of O3 is going to be 3 times, for oxygen it's 15.999. So my molar mass is going to be those added together. So I get 39.098 plus 14.007 plus 3 times 15.999. I get 101.102. That's what's going to go down here. And then finally, to find the number of grams of KNO3 that I have in 12.1 moles, we do 12.1 times 101.102 over 1, get 1,223, which rounds to 1,220 grams of KNO3. All right, and that is how you find molarity. Again, if there's one of these equations that is the most important, it's that one. Finding molarity, if you're given the moles in volume or mass in volume. Finding the volume, if you have the number of moles or the mass and the molarity. Or finding the mass or the number of moles if you're given the molarity and the volume. Just using that equation, rearrange and solve. The next video is just going to have a few examples of diluting solutions, which is our last topic to do with solutions.